Good afternoon, everyone. Welcome to the final presentation session of the Data Analytics Practice Opportunity 2024-2025. My name is Qingqing Zhang. I'm the Research Data Librarian here at the CUHK Library. We are so glad to have you join us, whether in person or online in the Zoom, as part of the Data Excellence Week 2025. The Data Analytics Practice Opportunity 2024-25 program provides students with opportunities to develop data analytics projects using real data to tell compelling stories. At this final presentation session, we'll showcase students' data analytics and visualization projects reusing data resources in the library and the university collections. Now, before we get started, I would like to invite Ms. Patti Chen, the Associate University Librarian at the CUHK Library, to give an opening remarks. Thank you very much, Patti.
Good afternoon, everyone. It's my pleasure to welcome you to the Data Analytics Practice Opportunity 2024-2025 final presentation section, co-organized by the CUHK Library and the Data Science and Policy Study Program at CUHK. The event exemplifies our commitment to encouraging data reuse and supporting to exploration of data and metadata from the university and library collections. I would like to express my great gratitude to Dr. Wong, representing the Data Science and Policy Study Program, for the ongoing collaboration and initiative with the library. The event also highlights the internal collaboration between the Digital Initiative Department and the Research Data Team, who co-host the Digital Scholarship and Research Data Workshop Series. Funded by the University Research Data Management Fund, the event promotes best practices in research data management, including data analysis and reuse. This event provides our students with invaluable opportunities to develop data analytics and projects using real data. By promoting data mining and visualization, we aim to equip our students with the skills and knowledge necessary to analyze data and tell compelling stories with the resources available at CUHK and the CUHK Library. This year marks the 4th year of the Data Analytics Practice Opportunity event. We are delighted to see the event flourish over the past 4 years, with students demonstrating their excellent abilities in data mining and visualization. Since the 2021-2022 academic year, cohorts of students have developed impressive projects that showcase their skills in reusing, analyzing, and visualizing data. Presentation posters, one of the student group student project deliverables, are displayed in the visualization room inside the Digital Scholarship Lab, just at our left-hand side. If you have time, please visit and take a look at these posters. They are also available on the library website for the Data Analytics Practice Opportunity. Each year, dedicated coaches from the CUHK Library and other departments on campus support and guide our students throughout the program. Special thanks go to Dr. Cherry Chen from the Institute of Chinese Studies and Mr. Sarah Chen from the Department of Chinese Language and Literature, who are serving as coaches for our student projects this year. We also have the library colleagues who are coaching students this year, including Ms. Sintra Zhang, Ms. Lily Ko, Mr. Ryan Lee, Ms. Kitty Siu, Qingqing Zhang, and Mr. Zhou Chen. Thank you all. We would also like to extend our special appreciation for our invited reviewers for the student presentation today, including Dr. Wong, Professor Bert Wing, Professor Lai Zitim, and Mr. Sarah Chen. Thank you so much for taking the time to review these presentations. Finally, I would like to extend my heartfelt thanks to all the participants, including student presenters, faculties, and staff members who have contributed to making this event a success. Your dedication and hard work are truly appreciated. Thank you for joining us today. I look forward to an engaging and inspiring event as we celebrate the achievement of our students and the power of data analytics.
you so much, Patti. Really appreciate the opening remarks. Next, we would like to invite Dr. Casey Wong from the Data Science and Policy Studies program to give his opening remarks. Thank you very much, Dr. Wong.
Good afternoon, everyone. It's an honor to be here today as a representative of the Data Science and Policy Studies program in the School of Governance and Policy Science. We are excited to collaborate with the CUHK Library on the Data Analytics Practice Opportunity for the 4th consecutive year. As Ms. Patti Cheung mentioned, the Data Analytics Practice Opportunity program exemplifies our shared commitment to encouraging the reuse of data and support the exploration of data and metadata from the university and library collections. As part of the CUHK School of Governance and Policy Science, our Data Science and Policy Studies program equips students with cutting-edge skills and knowledge to harness the power of data and drive policy innovations. Our mission is to foster a new generation of data service leaders who turn complex data into actionable insight and shape a better future for society. This shared mission has driven the collaboration that led to the launch of Data Analytics Practice Opportunity Program 4 years ago. Today, we are delighted to showcase 5 exceptional student group projects. These projects utilize data sources from the CUHK press release, Modern Words, CUHK 60 Anniversary Oral History Project, Daoist test collection, and the COVID-19 dataset. Our students have worked diligently, collaboratively, and creatively to develop programming code, analyze data, and create insightful visualizations that highlight the significance of these data sources. Throughout this year-long program, our student groups and coaches gather for a briefing session to kickstart the program, 3 progress sharing sessions, and now the final presentation session, which is today's program. Students and coaches also meet offline or exchange emails to brainstorm project proposals and fine-tune project details together. Their final deliverables include a web page showcasing the project, a print poster, as Patti mentioned, and the programming code used to mine, analyze, or visualize the data. We are also grateful to the invited faculty and staff members who will provide valuable feedback on the student project presentations. Their expertise and insights will enhance the learning experience of our students and help them refine their projects further. Thank you again for joining us today. We look forward to an engaging and inspiring event as we celebrate the achievement of students and the power of data analytics.
Thank you. Thank you very much. Thank you very much, Dr. Wong. Really appreciate your opening remarks as well. So let me just do some screen sharing here. Bear with me 1 second. Okay. So this year, we have 11 students working on 5 different projects. This opening slide shows you the project titles with the specific names for each group. This serves an overview introduction to the presentation session today. So the order of presentation will be the same as the presentation orders on the slide. So the first group, we have students using the data from the CUHK 60th Anniversary Oral History Collection. Xin Lam is a first-year MPhil student in the Department of History, and his teammate Xiaodong Huang is a second-year PhD student in the Department of History. And our second group project draws data information from a COVID-19 dataset by a faculty member here at CUHK. Both students, Yaru Wong and Yu Cheung, are first-year MSc Master of Science students in the Information Science and Technology Management. Cheung cannot be here with us today. So the third group's project uses data from the CHK press release. 2 students work on this project together. Xiaoting Lu is a first-year Master's of Arts student in Buddhist Studies, and Yanwen Huang is a first-year MPhil student in Mathematics. So the fourth group analyzed information from the Daoist classic. 3 students work on it in the back. Chen Chiu and Chuang Xin Ip and Yu Chin Sing are all 4th-year undergraduate students in the Artificial Intelligence Systems and Technologies program. And the 5th group uses information on Chinese modern poetry. Ga Xing-ai is a 3rd-year undergraduate student in the Computer Science department, and Chen Hin Chuan is a 3rd-year undergraduate student in Statistics. So as Patti just mentioned to us, we have also invited faculty and community members at CHK today to share the comments and feedback on the students' presentations. So including Professor Bert here from the Department of History, and Professor Lai Ji from the Center for Studies of Daoist Culture, and Dr. Casey Wong, of course, from the Data Science and Policy Studies program, and Ms. Daphne So from the Institute of Chinese Studies, and Mr. Sheila Chen from the Department of Chinese Languages and Literature. Now, in order to celebrate this final presentation, we will present to our students certificates of participation of the Data Analytics Practice Opportunity Program. May I now invite Ms. Patti Jen and Dr. Casey Wong again to sit in the front. Thank you so much, Patti and Dr. Wong, to present the certificates to our students. So we will go by the project groups and we'll get the certificates ready. And I will call each person by name. So first group is Column and Xiaodong, please come forward. Thank you, Patti. Thank you, thank you. Thank you. The second group will only have Yaru Wong with us today. Okay, so Dr. Wong will present. Yes, thank you. Yaru, please. So this is our second group using the data from a COVID-19 data set. Yeah, you can stay in the front. Thank you, thank you, thank you. Third group up, we have Xiaoting Lu and Yanwen Huang, please. Thank you. Fourth group, we have CCC. Okay, thank you. Yeah, he's representing the other group's members. Thank you. Thank you, thank you, thank you. Fifth group, we have Ga Xing-ai and Chen Cheung, please. Thank you. Thank you. So one last group picture. So please remain standing here. And we'd like to invite all the students to come to the front to take a picture with our opening speakers to have a group picture. And all of you, I think 10 of you all together. Yeah. So please come to the front. We'll take a picture with Patti and Dr. Wong. Thank you. Thank you very much, Patti. Thank you very much, Dr. Wong. Thank you, all the students. Okay, Now, we're very excited to hear the students' final presentations. After each presentation, there will be a Q&A session towards the end. Online audience can type in your questions in the Zoom chat box, or if you're on site, please raise your hand and we'll pass you on the mic. Then you can ask your questions. So our first group is by Colin and Xiaodong.
And hello, everyone. And I'm Colin from the History Department. And today our project is about revisiting CUHK 60th Anniversary Oral History Project. So we have two parts to introduce you guys. So one is about the LDA, and second part is about the interactive map. So first of all, I think we have to introduce our objective first. So our objective, simply put, one sentence: exploring the collective memories over the CUHK, the alumni. So, but how we get to do it? I think out two ways. So one is the LDA, and second part is about the interactive map. So, but first of all, I think we have to talk about how we do something in the data set and how to connect it. So yeah, the data set. So it provided by the All History project team, right? And you will see the picture in the left. Okay. You see that is a video, and they provide a very brief description about the transcription. So beyond that thing, we wanted to get a full transcript of the Cantonese transcript. So and in this project, we just focus on the 31 interviewees, because that is in before the 70s. So we focus on that data, and we have to do is to get the complete Cantonese transcript provided. So this is about the data preparation, but I will talk about more later, because in the topic modeling part and also in the interactive map part, the data will be deal with the different rate completely. So yeah, but how we got the Cantonese transcript first? So you see, so that is about code, but today we will not focus on the code, but a very briefly introduction to you guys is I'm using the Hugging Face Transformers library and to load the pre-trained model, and that model we call is the Ivan Lee, and that I think not it's quite good, but not enough. And because about some factors like the people accent or the network issue, because some of the interview is conducted by the Zoom, so that will impact the quality of the video. So so how we modify it is I will use the Copilot AI here. So I just give some points that to train our model. Like I will reuse that the brief description that I mentioned before, and to put it in, and I will mention it that is a written Chinese test, and the transcript that we how to say it get from the Ivan Lee model that we call the spoken version, and use the written Chinese test to train our AI, and finally we will get a much better version of the Cantonese transcript. And but they still have some problem on it. Then I will mentally fix it. So I will show you the example first. So you see the before one. The before one is the Ivan Lee model, the result of the Ivan Lee model, and after one is the after the Copilot AI. So and you see the before one like the 用演講 and 重機 and something like 重機 like and 九路, and that like the people names and the specific term and maybe the location cannot be actually transformed by the Ivan Lee. But after we use the Copilot to fix it, and you see that that is much better, because we have the very brief description from the All History project team to the website. And yeah, and after we got a set of the data, the 31 interviewee, so what we have to do is to move in our first part, the LDA, the topic modeling. So briefly, what is the LDA feature here is that I don't want to label the data, but I still want to explore some new topic here. So that's why I'm used LDA, and that is an algorithm. And here I'm used the LDA with the Jameson. Yeah, should be that pronunciation. And want to uncover the hidden topic structure here. So, but I still have some static things that we have to do, and that is the pre-processing the test. And some part here, I will talk about why I'm doing like that. Like we have to do the segmentation and stop word removal, and we have to add the dictionary, and we have to decide the number of the topics. So, and I will use the Java here, and yeah, I will explain you why. And I will use the 19 topics because the functions from the Gensim have one called the coherence model and could be rate your topics, get a mass, and that's quite a relatively high 19. And yeah, and first thing I have to add a dictionary, and like and you see the right one. What I have to add is the name, the people name, and also the place and something Cantonese terms like 大排檔, like 巴士, and that is difficult for the LDA. Could be got it, and that's why I have to add it. And second is the stop words. Some non-meaningful terms, I have to remove it. I have to remove it. So something like the 走咧嘅係, that is very special in the Cantonese because you have a lot of the stop words have to remove. And yeah, but that's actually why I use a Java, because when I use the Java, I have to add a lot of the stop words. Actually, I can choose like the Pi Cantonese, but how to say, technically, the Pi Cantonese have no the functions with the dictionary. So actually, the result is not quite good. So finally, I use the Java with the dictionary and create a list of the stop words. Actually, we get a much better the result. And the example of what the LDA do. Like I'll just give you the topic 1 and topic 8. You just follow the result of the topic, and you will see some hidden topic there. Like the topic 1, I just locate graduation, but you, New Asia College, 生涯書院, and also the form bond, like yeah, and you can get a hidden topic here. This is about the admission, and maybe a story about the student in a Chinese medium instruction school after the announcement of the examination result and being admitted to the A college or the UC. And the topic 8 is about, you can see also the keywords, 新亞書院, a New Asia College, and 60s, 60年代, and 精英 elite, and we can guess. Another one is about the life and the self-identity of the student studying in the New Asia College, and they maybe consider themselves is elite. And we have the visualizing part, and I will show you and try to give you an explanation, right? Yeah, you see that is a very interactive, not very interactive, but interactive array. You can see when you click the next topic, and you will see that there have a lot of the circle, and that is the function called the PyLDVs. Right? And you can create an intro topic, and in the topic distance map, and there have you see the right hand side have a lot of the words, but actually that is not related to the topic, but that is the top 30 frequent words exist in that text that's associated with the topic, right? And you see the different like the one I will show you later, and the distance between the circle is show the similarity of its topic, and also the size, the circle size is represent the proportion of the text value associated with the topic. So I will show you. So right, not this. The topic, the one is the left, and it is the right. And what this picture show us is about the LDA model think the topic 1 and 8 is not very related. here. But you can judge it actually. And the third part, so that is the interactive map. So right, talk about the data preparation first. So completely different to the LDA. In the interactive map, we have to create the Excel file, and we have to have two tables here. And one is about the location, and we have to add the coordinate. So you see the longitude and latitude, and also we have the label. We want to locate, because one of the main object here, the interactive map that I want to do is to try to find out the location associated with the memories in the active map. So and we will have the table location, and yeah, also we have the tab, the what exactly the location is. Like you see the Shungi Wingqi is the CC. And other table we have is the people names and what their memories have. And we see the example, we have to the column, the 唐端整, and also the location, because we have at least one column should be the same. For the join and relate function, I will talk about later. And the code, what the code means is the collective memory, the memory here. And I will talk about how to capture it later. And you see the sources. And we will refer to the all history project team website. And yeah. And talk about how I captured that location and also how I captured that code. I'm using PyCanalyst here. So to do the word segmentation instead of the Java. But and also some very simply function that I use is I try to how to say it, to divide a sentence, but use the suffix, use the word to divide that sentence. And when the program note that word is in that sentence, and that I will capture that whole sentence down. And you see, so what I have to do here is I have to add an extract location list. So like the 樓, like the 書院, like the 學院, 餐廳館, something like that. And I will get the extract location here by define the sentence of the word. And that is the example. So you see the extract location, that line, and because I enter the 大學 and I enter the 校, something like that, as a suffix that I want to find out. And you will see the and the sentence we will I can jot it down. And you see that 嗰時候中文大學仲未成立 because they have the 大學 these words, and the sentence will be locate and mark it down. And now I have the location, and I have two table. And what I have to do further is I using the ArcGIS, and I try to join the table together. I join the location table to the coast table, to the coast file. And finally, after that, you just use the from table to point function that will get a map, and you can make some logo there, and I will show you the different layers. But you see in the word level, actually have some people that I remember is in the Columbia University, because the UC college actually is formed by the Columbia University president before. And you see the different people's the memories over the world is over the Hong Kong. And here you will see that they have a lot of the layers. And if you don't want to see all the points, and you can choose the like the CUHK, you see the places, the different places, and you see the like here, and you will see very clear that is Weibo. So I show it by logo, by using logo CUHK logo, and different is you see the New Asia College, I use the New Asia College logo, something like that. Right, and also here is doing a georeference. I actually provided by our coach Kitty Siu, and right, I georef, and we have the georef the 60 feet campus map here, and here is the demonstrate video. So let's see. When we zoom to the layers Hong Kong, and you will see the actually the different logo, and you just follow the logo, and you see the CUHK logo is like how to say it, some people's memories over there. And yeah, we jump to, if we don't, today I just want to talk about the NA college. So we just remove other logo, we must move off other layers. We just focus on the NA college, and you may think about a problem why in the NA college in the Meunier campus just have three a logo here, and that I will explain why, because at that time maybe the main campus is located in the Long Po Do in the Guai Lam Gai, and you go to the I remember I clicked the Guai Lam Gai first. Yeah, we will be at Guai Lam Gai. Here is Guai Lam Gai, and you will see the have the different options because that more than one people have the memories or talk about the Guai Lam Gai campus here, and you will see the different column like the name, location, and the codes, and also the sources have a in the pop-up window. So, and yeah, here is the Ga Lam Bin Do one, and they have borrowed some classroom from the Ga Lam Bin Do campus. And also this is the Azhou Menshan Ye Yuan. And follow this map, you can clearly to find out their memories attached to the location. And also here is the very famous one, the Long Po Do, and now it's the Shanghai Zhonghe. And you can just follow the different like that one is the Yuntang, and that one is the Shen Su Yun, the whole things. If I cannot locate the exactly if the people just mention the Shen Su Yun instead of the specific place, and I will just mark it as the Shen Su Yun model, and you will see that is the effect. And next part is what I talk about. You cannot find it a bit in the main campus now, because at that time they haven't been moved to the Meunier. And yeah, for the pond, you will see that they are in the different place. They're in the farm row or the Guai Lam Gai. And yeah, and we just focus on some story here, and you can see the everyday moments by building this GIS map. And this one is the Lei Yanhan, and you can see he mentioned the New Asia boat is a place for the people to chatting. And also you can see the different opinions here by using the choosing the different people's names. And you can see that maybe they will a little bit proud of their campus, or maybe they will mention some people's names that is be lost in the LDA model, because LDA model would not think about the people names would be a topic, or so actually the map is supplement this miss here. And also, if you see the Guai Lam Gai, and you see the different story, because that is the hardest moments there, and you see the try to describe their schoolmate, the situation, and that is quite tough. But yeah, but and they maybe you see it, and but they have a very good relationship. You see that is the tough, but a very good old times. So, and maybe you see the different opinion, like some people think that campus is not quite good for him. And right, so make a quick conclusion. So this project actually is using the topic modeling and also the interactive map
and try to provide us a very quick view of the CUHK alumni's memories and life. And also I want to use the question Q&A to end this part. Like we can answer some question here, like what is the student life like at the New Asia College, and also by the LDA and also the interactive map, we see they may be very proud of their identity and campus. But more than that, as I mentioned before, is the map also highlights some hardness moment, because maybe just few people experience the Guilin Guide period. And in the LDA part, because the pool is too large and they cannot identify such topic. And so that is what the map could be supplement to the LDA, and different way could be make the result fruitful. And other question is, why do they study at the NA college? And you see the LDA and also the map views also see the same point here, is maybe they having attend a Chinese medium instruction school, and they have a very limited choice. Yeah, and right, that's it. And finally, I want to thank you to our coach, the Kitty Siu, and also the Xinxia Zhen a lot. And yeah, that is the presentation, my presentation to date. And right, thank you.
Very much again, Colin, for the very wonderful presentation. Do we have any questions from the audience on site and online? Oh, yeah, Dr. Wong, please. Thank you.
Can you go back to the slide about the LDA?
Yeah, sure.
The output of LDA, you got so many clusters, right? Topics.
Yes.
Have you ever tried to understand these topics? Give a meaningful name to each topic generated by LDA?
No, not yet. Actually, I just try to fill the.
So it's so many topics. How many? How many are there?
19.
19.
Yeah.
And can you show the circles, all the circle? I see that the third one and the 13th one, right? The number 13, right? Is it within the whole?
Yes.
Yeah. The overlap. Completed overlap.
You mean this one? Yes. But actually, I how to say it? Talk about the theory. I have not quite have the knowledge about it. But for the topics, I think the 19 is quite a good performance here. I'm not sure, because you can rate it, and actually around 0 and 67 points there. But actually, if you mentioned the covenant, because the circle is not about the actually is not related to the topic. Because the circle size is because the words they share some words, they mention the same words in their topic. Like the 13, they have a topic about maybe school, and the third one maybe they about maybe this one is maybe about school life, and this one is about maybe CUHK, and they will share some words together. Because here you see the words, it cannot to refer to the topic exactly, because the words is about the test using this word frequently in that topic. And actually, one test could have a lot of topic. And finally, you will see it's very overlap here.
But I suggest that you try to give meaningful name to each circle.
Okay.
Yeah. For the topic.
Because at first time I don't want to do this so fast.
Because the number themselves cannot give you any meaning of the
yeah
topic.
that is good feedback. Good comments, right? Yeah.
Thank you, Dr. Wong and Colin. Any more questions? Oh, Ryan, please.
Yes, I have one question and one comment. the question is, my question is, why you in your LDA you use JBA as a segmentation, but after that you use the PY Cantonese?
Oh yes, because the PY Cantonese have no dictionary function.
Oh, okay.
But the Java, because they have the dictionary function, and I can, because I think the difficulty, they share the same difficulty. The people names, the not the specific term, like the 生拿书云, and some people mention the 损基书云 in their interview, and so that's why I have to make a dictionary to specific let the model know that term.
My other comment is you did mention about you want to use the LDA and the interactive map together. Maybe just a suggestion, if you are using the interactive map, you might add the related topic in that place, so people can refer back to this topic, what they can talk about. So seems now you have two different tools, but you can make it more integration together.
Yeah, I will fix it in the website version.
Great. Thank you so much, Colin. Again, we'll now invite Professor Wong to give some comments and review on the presentation. Thank you so much, Professor Bo.
Thank you all for giving me this opportunity to learn something about digital humanities. I must say I learned a lot of terms without really understanding them, and also the techniques. And on the whole, I think it's a very new way of research, and I hope you haven't spent too much time. May I ask? I should ask this question during the Q&A time. How many hours? How many working hours do two of you totally spend?
Actually, for the data preparation, more than 1 month. But after that part is within the 1 week.
Okay, right.
Always the data set is the difficult part for us to do it, because the Cantonese transcription is not very advanced in that field. So I have to put a lot of effort to fix it.
Right. Yes. I have the feeling that this method, these research methods or tools might work better for perhaps not very systematic data. For this sort of for this 31 click for these 31 interviews, they have some sort of cultural connections, which it seems to me that you don't really need these tools to appreciate. On the other hand, having this visualized data and also the map, yes, ArcGIS. Even with that, perhaps you couldn't really appreciate, for example, Mr. He Man-sim's humor and Mr. Tong Dun-jing's very touching charisma. So on the other hand, if these were, say, all fragmented memories, or perhaps there was a war, and then all we had left is very individual fragmented clips, that maybe it would help. So, but anyway, I'm learning. So I'm sure there will be a great potential for digital humanities. Thank you very much.
Thank you. Thank you very much. Thank you very much for your comments, and thank you very much again, Colin, for your excellent presentation here. So next group will have Wong to present us on a data set about COVID-19.
Hi everyone, so today I'm going to introduce you a key data set used in our research, COVID-19 rumor data set on the Weibo platform, and this is the the data set looks like, and we can see that the column name will have the post ID, the parent ID, current ID, content, something like that, and the source is by a research team at the CUHK, which was designed to help analyze the rumor spread patterns, user behaviors, and the emotional dynamics on the social media during the pandemic. So next, we based on this data set, we will further explore the characteristic and the propagation rule of the COVID-19 rumors through the visualization, sentiment analysis, and other methods. And we finally provide the references for the social media governance and public scientific communication. So the next part is the visualization part. We actually divide into the two ways. So the first way is to visualize the user distribution, and the second way is to visualize the category distribution. So for the first way, we have the two graphs, the user gender distribution and the verified user distribution. So we can see that on the left graph, the chart shows a significant differences on the number of the male and female users, since they all have the large content here. So we may not see the obvious, the significant on the graph here, but it still has the huge differences here. So we can see that this is a female majority per platform. This is a female majority user based platform, and which might influence the type of the content that is more popular or the way information spreads on the platform. And this graph highlights the gender imbalance and its potential impact on the content preferences and the engagement. It discusses how this distribution might affect the spread of the information, especially related to this topic. And the platform has a large number of the regular users, and it emphasizes the dominance of the unverified users and the potential implications for the content credibilities on the right graph, which is the verified user distribution. And it also discusses how the low percentage of the verified users might affect the spread of the misinformation. So we go to the next part, the post category distribution and the post by hours. So on the left graph, we see that there are two categories, the other category and the COVID-19 category. The other category has a significantly higher number of the posts. Despite the lower count, the COVID-19 category is still substantial. Indicate that the pandemic is the major topic of the discussion on the platform at that time. Yeah, and on the right graph, the posts by the hour, there are two distinct peaks here. We can see that from the 0 to 1 a.m. and from the from the 8 to the 11 p.m. in the evening, and they are the key times for the content sharing and engagement. So we can see that there are high interaction during the day, may be related to the fragmented time, such as the work breaks and lunch breaks, reflecting the time dependence of the users' emotional expression. And the positive content spread more easily during the peak hours, which can provide the time-sensitive strategies for the anti-rumor campaigns, such as the pushing scientific information during the activity hours to hedge against the negative emotions. And we think that this is the golden window for the emotional transmission. So the third part, we talk about the sentiment analysis. So we actually using the Python Streamlining library to draw the map, and mainly to distinguish the main spread paths of the different posts, text content, and the sentiment analysis. So we first analyze the path of the rumor. The first, the propagation path dynamic graph is drawn here. There are multiple obvious central nodes we can see here, and represent the key users of the propagation. These nodes are high impact users who plays an important role in promoting the spread of the rumors. The rumors spread from the central node to the outside layer by layer, indicate that the rumors generally spread to the wider network through the multiple level of the propagation. And next part, we visualize use the word cloud here, and so we can see that we enter the post ID, and this is the word cloud for this post ID, and we can see that through this picture, it can be there are many negative adjectives for this rumor, such as terrible, horrible, and ridiculous. So this word indicate that the content may have triggered the negative emotions, such as the anger and anxiety. And for the sentiment score here, we for this post ID, we find that the overall sentiment is negative, and the average sentiment score is 0.34. Some scores are distributed from the 0.2 to the 0.3, which is more negative, and the few scores are distributed in the 0.45 or more, which is slightly positive here. And the result of the emotion analysis shows that the overall content tends to be negative here. And the distribution is mainly concentrated in the negative segment from the 0.3 to the 0.4 here. And the next part is the daily sentiment score. So the picture on the left is the time distribution of the sentiment score in the of this post, and in which that we can see that on the January score, January 30, they have the lowest average sentiment score here, which is the 0.34. And we can take a look at the specific evaluation of that content of this day here. And it can be seen that people have a high negative informations, and in the future, it may be possible to eliminate the panic mentality of the passive by refuting the rumors or popularizing the related rumor values. So at the same time, we selected a non-rumor related to the COVID-19 for the comparative analysis. So so I have to mention that this propagation graph, so we actually can click the nodes and show the content here, and this is the content details here, and this is the rumor refuting types of the post, and the content of the original post is mainly on the rumor refuting and the popular sites related to the knowledge, and the propagation of the rumors can be seen here, and the overall propagation trend is more single and centralized, while the propagation path of the rumor can be seen the multi-centralized. And we actually based on this content to do the word cloud here, and we find that so there are some scientific keywords for this content, and it's about the facts of the refuting rumors. And we think that since this is content is the refuting rumors, but the overall sentiment score is still the negative, so we have the new problem arise. So why a non-rumor Weibo post is defined as a negative sentiment score? So we think that although it is not a rumor, but its content involves the nature of the refuting rumors, and it's possible that like some more negative words, like in the discussion here, may cause a lower score in the sentiment analysis. And it is the pre-training set of the Bert's model directly used, and it does not really adapt to the content of the microblog speech on the whole, and it may not be clear about the sentiment analysis recognition of some words, and this is also like we need to improve in the future studies here. And the last part we want to talk about is the conclusion part. And since all the sentence is in the PowerPoint, so I will like quickly go through it. So we have the two conclusions here. So we think that the rumors generally like spread through the multiple centers of the important users as the propagation path shown before. And we think that the rumors with the negative emotions can spread faster, and the rumors with the neutral and positive information may like limited due to the lack of the conflicts. And in our project, so we think that the future study can be these four aspects. Like first, we can train the own Bert model after tagging our own crops, and we can explore the more suitable models for the sentiment analysis, and train to discriminate the rumor text content for the prediction. Also, the last one is keep digging for the topics or events that trigger negative informations. Yeah, that's all. Thank you. Any questions?
Thank you very much, Yaru, for your presentation. Now it's a Q&A session. Do we have any questions from the audience here on site and online? Yeah, Dr. Wong, please.
Yeah, I'm a little bit confused about the purpose of the study. Can you go back to the
Okay. Which one?
Sentiment analysis?
Yeah.
Because before the sentiment analysis, you seem to doing to detect whether the rumor is true or false, right?
Yeah.
And then now you move to measuring the sentiment analysis.
Yes.
You want to find a relationship between these two, right? Whether true rumor or false rumor have negative or positive sentiment, right? And
Yes.
then classify or find out the string or spread, right, of those rumor. We find that sentiment with highly negative, right, will spread faster than rumor, right, with more positive sentiment. Is it one of your purpose to?
Yeah, so like I think so I want to like tell more like stories behind the project. So the first like in the beginning of the project, so we actually didn't get like so you can say like this data set is not the original one, because like in the beginning the data set we gotten is not like so much information here. So thanks to the Qingqing and Zhong, they reach out the research team, and they like upload the more detailed data sets. So that's why like we have the more information to visualize, because for the beginning, so we didn't have the kind of the description of the content, and we even don't know the parent ID and the current ID. We only know the post ID and the the category of for the like COVID-19 and others. So we actually didn't have much information to visualize. So this is kind of this data set like I show here is basically like kind of the combined to the 4 region of the data set. So yeah, I know your question is about the like to clarify the purpose. So we like my team member and I will like give the very specific purpose like on the like we are shown in the poster and the web page. Yeah.
Yeah.
Thank you.
Thank you.
We have actually a question from online. How did you collect the Weibo data?
Yeah, I mean, this question should be asked to the research team.
Oh, okay.
Yeah, yeah, we just like, they upload their data sets on this link here.
I'm Lily from the CUHK Library. May I supplement that because the research data management, we have the project, so we call Research Data Management Fund. So these are Weibo data. Actually, the researcher, he applied for the RDM fund and got the fund. So that is what the research they did, and they share their results, the research data on the web. So our group use this data for this project.
Yeah. Yes.
And may I ask a question? So you're using the Bert model. Can you tell us more about this model to provide some information for us?
Oh, okay. So like this model is like generally like to like analyzing the social media data. And so we actually have another model like called I don't know how to pronounce, but it's like it's the SNOWNLP, and we actually like do the comparison between these 2 models, and we find that like the Bert's model is more suitable and it's like kind of more like more popular model to use to analyze the social media platform content. Yeah.
Thank you for sharing the information.
Yeah, I also want to ask, in the data set, there's a column called rumor, right?
Yes.
So it's a label of that post, whether it is rumor or not rumor.
Yes.
Okay, so there are some posts labeled with true, right?
Yeah, it's kind of the false or true in this column. It's kind of the boolean. Yeah.
Okay.
Great. Thank you. Actually,
I actually got one interesting question because I saw that there are like the content of the rumor or not. There are also like kind of the username of those creators. I was wondering if it's if you have done something like to detect like what kind of rumor are more likely to be reposted, and who is those reposters. Like I think that's going to be a little bit more useful because like we can find out like who is more vulnerable to those rumors, which can kind of.
Yeah. I think that's a very interesting topic for our project. Like maybe like I will discuss with my team members.
Yeah. I know it takes much more. Maybe it takes much more time, but I think it's interesting.
Yeah, because it's like the latest data sets uploaded in like on the website is actually very large. It's kind of like the 100. I don't know, like I don't remember correctly, but it's like too much.
Yeah. I think I'm also interested in Weibo data, but I don't have the way to scrap that. But I'm glad to find out there is. I will check it later.
But it's kind of like more negative comment here.
Yeah, thank you.
Yes.
Thank you very much again for your great presentation. Yeah, we really appreciate that. We have appreciated your entertainment of the questions as well. Thank you so much. Great job. Thank you. Thank you. Next, we have our third group, and presenters are Xiaoting and Yanwen. Please.
Yeah, hello everyone, and we are group 3, and my name is Xiaoting, and you can also call me Shelly.
And my name is Yanwen. You can call me James.
Yes, our group's topic is the Streamlining Research, a comprehensive searching platform for CUHK press releases. Okay, sorry. And first, we will introduce the CUHK press releases. When we got the data set from the university archives, we separated the press release into 2 parts. The first part is 1983 to 1997, and the second part is 1983 to 1997, and the second part is 1998 to 2006. And we will explain why we will divide it into 2 parts later. And after we read this press releases, we find that there are too many kinds of events recorded in these releases, such as the student academic performances, like the professor appointment or the seminar or scholarship and so on. So we think these press releases record the history, progress, and the development at CUHK, and so we think it's really important to do this project to deal with the CUHK press release.
And next, I will introduce the whole workflow of our project. First, our workflow is divided into parallel parts. One is for the data processing. For this part, we will go through OCR and use some large language model to enhance the OCR result. And after we get the OCR result, we can do the document understanding by using some models to understand and read the document and understand it. And we can combine the same events together, and we can also add the labels for each event. And the second workflow is about the platform developing. Since we want to do to develop an interactive platform that users can click and see the timeline of the whole development of CUHK history. And this platform is developed by Python and Dash, and it will include such functions like calendar and timeline, and also the event statics. And we can also do a search and the filter for the events, and also we can see the details of each event, and we can also download the original document.
And yes, and I will talk about our project of the first part is the data processing, and first, we see that in datasets that during the 1983 to 1997, and our document was in the PDF format. And the second part is 1998 to 2006 and is in HTML format. And we find that in the HTML format, we can just directly extract all the words in it and put in the and to do with our second part. But for the first step, we will focus. It needs us to deal with it first, because the AI cannot extract the word here directly. So we'll introduce how we deal with the data in the first part. And yes, for the first part, we will OCR this document. And first, we use Paddle to do the first step OCR. And on the right side, we see this is the data we do with after the Paddle, and we will see there is so many mistakes here. Like we see there was a words missing, like the 高级师, and we see that there is some mistake and like what does mean by 路人, and also we see the words some words are in the wrong like we see that is 983眼腰, and it's a lot of mistake that we cannot use it directly. So then we have our second step. And second step, we use the Grok 3 to enhance the accuracy of the OCR results, and that is the left side is the content we put in the graph tree, and the right content is the content that deal with after the graph tree. We see that the graph tree has already corrected the mistakes here. And it also summarized the events. And due to the AI restriction, we cannot get the 100% corresponding information. But the graph tree will automatically extract the keywords like the places, the name, and like the seminar topic, and it will extract the key information and to generate the summary of this event. And it is enough for the researcher or the public to get the press release they need. And third, we also let the graph tree to add free labels for every event automatically. And besides this, we also let the graph tree to combine the document of the same event. If this event have both the Chinese version and the English version, and then we ask graph tree to combine these two versions into one content, and this is for our second step. And now this is our prompt to graph tree. And then we will invite James to introduce our second part, how to do an interactive platform for this CUHK press release.
Thanks, Shirley. And now I'll introduce about our platform for the users can view the events interactively. And this is the overview of our whole platform. And here is a search box. We can search for the different events. And here is a topic filter, and we can choose the topics we are interested in. And here is a calendar. We can select it. And this is time frame we want to focus on. And we can also use this timeline slider to have an overview of the whole history of the university events. And here is the events we showed. And here is a pie chart, and we can see the distribution of the different kind of events. And next, I will first introduce how we divide these events into different categories. Since we have already get some labels from Grok after the data processing part, but since there are too many kind of labels, but some of them have some similar meanings. So we also use Grok to generate a dictionary. Like for the academic, it will include this part of events. And for the cultural one, and it will include this part of events. And we combine this group the events with a similar label text, and we finally get 10 different categories. Yeah. And then next, I will introduce some functions in our platform. And first is about the calendar. The user can click here and select the dates they want to focus on, and this timeline will automatically change according to this time the user selected. And next is about the timeline slider. Besides of the user calendar, the user can also slide on this slider and directly to change the timeline. And this date here will automatically change according to this slider. And next is about the search box. The user can search here by both Chinese and English, and to search the events they are interested in. For example, there is a search about the art museum, Mamagun, and here is some events according to the art museum events. Here, yeah. And next is about the event filter. We can, besides of using the box, we can also do the search by the filter. For example, here we choose a donation, and here is some events related to the donate part. And finally, it's about the content preview part. And for each event, we can also click the event and to see look into the details of each event. Like for here, for example, if we click here, we can see the intro content of the event in a box. And then here is the original document linked to our web. This is the image for the preview. And then here it can also link to the library website. And the user want to view the full document in PDF form, and they can also click this button and we can download the PDF from the server.
Talk about the significance of our project, and we think that our project both target at the researchers and also the general public. And we think that for the researchers, this interactive platform can enable a quick and efficient extraction of the press release that they needed, and the platform provides insight into the proportion of specific types of press releases within a specific or a given time period. And then for the general public, and we think that the platform can facilitate the fast searches for the press release content of that they are interested in. And also this platform offers an understanding of the university historical development process. And finally, we invite James to talk about the future development of our project.
Thanks, Shirley. And next, I'll introduce about our further development. And the first is about the data part. Since we only process the data between the 1983 to 1997, and for 1998 and to 2006 part, we haven't not processed it. But we do not need the OCR part for this part of data. We can directly copy the text and let the AI to understand the words and add labels for them as similar as before. And the second part is there is also some issues inside the data, but we still not far fix it. Like for some events between the 1983 to 1997, some events lose the title. So for this time, we still not add the title for them. Like the title is like the press on the 1983 on some day. It's not a general event. And for next part, and also the platform, since this platform now is only deployed on our local device, and if we have chance, we also want to deploy it on an online server, like on the library's website, and the users can go access this platform and to see what happens when between the 1983 to 2006. And we can also add the newest data, like the data after 2006, if we can get it. And this is about our further development.
Yes, and this is our presentation. Thank you of you. And also we want to thank our coaches, Sintra, so she's not here today, and Ryan Lee for their help for us. Thank you.
Thank you.
Thank you very much, Xiaoting and Yanwen. Thank you. Do you have any questions from the audience for this presentation? Or any? Yes. Dr. Casey.
Yeah, I cannot. Can you tell me more about how you use Grok3?
How we use Grok3,
yes. To do what? I forgot. Yeah.
Yes, we use Grok3. The left content is the data that we receive from the pedal, and we put this data to Grok3, and we used our prompt here, and this our prompt here, and then it will generate the content on the right side.
Or in both Chinese and English.
If this event both have the Chinese and English version.
Okay.
Yeah, and this is our prompt, and we can divide it to 3 parts. Like the first part is what is the task we want the Grok3 to do, and this is one output example to make the output in the format we want. And also this is for the second part, since if we do not add this like this combine same event together, we already say it before, but if we do not say it secondly, the AI may forget this event. This is some point we want to stress for the AIs to focus on.
Why you chose Grok3?
This is what we told the Grok3.
Why you chose this LLM? Why Grok3 LLM? Maybe not DeepSeek, for example.
Because most
we have tried some other also like ChatGPT and also the Google one and also the Microsoft Copilot, and we found the Grok 3 first it is free, and yeah, and second it is the most accurate model among the all free models.
Yeah, that's great. Thank you. Any other questions? Yeah, Professor, please.
Just a quick question. So after using the Grok 3, will you also verify by yourself?
Yeah.
Yes, we will verify by ourselves because we see sometimes it may make mistakes. It's like it's not follow the structure, or it may sometimes have some unexpected mistakes. So we will verify by ourselves.
Yes. The next question is, if we use the conventional old school method of somehow typing all this out and then correct the mistake or by the along the way, which one is more time consuming or time saving?
I think that this if you use Grok is much time saving, but because it can do with the graphic. How many times the graphic deal with one content?
For we separate the data set to like we combine the 3 events together and upload to Grok for one time, and it takes about less than 5 minutes to finish all the things for the 3 events, 30 events. And for this mistake check, we only need to check the format and whether the title and the content whether they are matching. Since for this content, I found that almost no mistakes for the Grok 3 output.
Yeah, that's why I put on this question, because this seems to be can be done right manually.
Yeah.
Maybe if you done it manually, maybe it take less time than go through all these steps. Using large language model or OCR.
Finish it manually, maybe it takes more than 1 or 2 hours. Yeah, since we first need to read the whole article and then stretch some in key points and let it to be in this kind of format.
So how much time you spend on the OCR?
Maybe
OCR.
the whole maybe.
If we add, since we do it not finish on one day, if we add the time together, maybe I think 1 day is okay. Oh, like 24 hours.
But then you have to find out the error and then get the LLM to correct them.
Yeah.
But it also took time, right? This process.
Yeah, you also need some time too.
But overall, maybe I don't know. Both of you save time or you spend more time.
Yeah.
I don't know. The whole process. Yeah.
Any other questions? I think maybe someone in the back or Ryan, please.
Question. Yeah, but I also want to add, that I think that one can be done manually, but the human also can make error. So you need to verify after that. Yeah, and also the human verify is inconsistent. Machine error is more consistent from my experience. Just one comment, one question. The comment is, I think, because you have two set of the data set. One is the before 1997, one is after that. So I think you are very brave to take usually people will take the HTML rather than to do the OCR. But I think it's good you use the OCR to evaluate the OCR, the limitation, and using the LM to experiment to see that one can correct the text. My question is, just curiosity. When you use your map, I want to see the interaction map. You use the Manmatgun as an example, right? Can you show the 圖書館? So because you're holding in the 圖書館, because no event in 圖書館.
Yeah, we want to show it, but since today we can only use the PowerPoint. Yeah. If we can log into our platform, we can search it. Yeah.
Okay.
Right. And any other questions? If no, would Dr. Casey give some further comments on this project? Thank you very much.
Can you show me the conclusion part? You said for the public, right? So offer understanding of university historical process. Can you Can you summarize your findings on this?
Sure. I think that for the public, maybe they who is interested in the development, like the 图书馆, and he has just searched the. Maybe you can just search the. In here we can. Sorry, no, it's just the data. And maybe he or she can search the 图书馆, and he will, and the platform will show all the events that happened in library that the public then can got the press release. They want to know.
Okay. I found this interactive platform very impressive. They all agree with it, very impressive. Okay, I look forward to your further development in the future. Thank you.
Thank you. Thank you very much, Xiaoting and Wong again for your great presentation. Really appreciate your time and efforts on this project. Thank you very much for all the questions. So now that concludes the first part of the presentations. We'll take 15 minutes break. Please come back at 2:15. Welcome back from our break. So the second session will start with our fourth group of students presentation on the Daoist Classic. So let's welcome CCC and his teammates Henry and Cheung. Thank you.
So good afternoon, everyone. We are the Daoist text collection team, and our project is 呂祖全書 Daoist topic retrieval engine. So I'm one of the team representatives. I'm Cheung CCC.
And I'm Cheung Henry.
Sheng. Okay, so let's begin. Let's begin today's sharing. And in today's sharing, we'll like to walk you through with what we have did. So we have did text segmentation, visualization, topic retrieval. We've made an UI, and last but not least, we'll do a demo in today's sharing. So let's dive in. First of all, we have got our raw data set, which is the 呂祖全書32卷附涉中政治 from the Centers for Study of Daoist Culture. So from the example on the left, you can see that the segmentations and the punctuation of that text is not the same as what we are familiar with nowadays. There's no commas, and the segmentations are all segmented by full stops. So what we plan to do, or what we plan to work on this text, is that we'd like to add punctuations. We'd like to redocument the whole text into sentences and paragraphs. Why are we doing so? Because we'd like to support further downstream analysis, which is paragraphs retrieval. And why we have to do so, we'll tell you later when we are talking about the retrieval. Okay, first of all, let's talk about the text segmentation. So how we do the text segmentations? First, we divide the text by volumes. So this by algorithms. In the text, they're separated by like 卷1, 卷2, 卷32, etc. So with algorithms, we separate them into volumes, and then we segment the text by algorithms. What means by segment the text by algorithm is it's like we define the text again with the new line character. And then we do data cleaning. So just like the example we show in here, there's some punctuations that is somehow make no sense. And we think that there are some unwanted punctuations like the @ sign. So we remove those punctuations. And after this processing, we find out the statistic is that on average, in one passage, there are like 97 words, but the maximum word count in one passage could up to 7,700, and the number of passage is 3,615. We don't want the passage to be too large, because it will be useless if we are doing paragraphs retrieval in the future, if we are having such a large paragraphs. Therefore, we do the second segmentation with AI. So the AI we use is Yuan from Hugging Phrase. I'm sorry that we didn't type in here. Why we are using AI to do segmentation is that we'll like to limit the paragraph size, and we want them to be less than 256 words. And after we do the AI segmentation, we do data cleaning again to remove punctuations that the AI generated, which is also unwanted. And from the statistic, we are now having 4,277 passage, the minimum word count of one passage is 1, the maximum is 256. So on the left, that is one of the examples of the original text and the final segment text that we're having. So you can see now the text looks like what we're familiar right now with commas and full stop, question mark, etc. Okay, so after we do the segmentations, the another important thing is how we evaluate the quality of our segmentations. So in this part, we have built our own evaluation data set by collecting quotes on 呂祖全書 from academic papers. We have used 3 different papers that is about 呂祖全書. One is 呂祖全書正宗清代北京 國元壇的歷史及其呂祖天仙派信仰, and also the another 2. So these 3 papers is all from Professor Lai. Yeah. We have collected 25 quotes and we have broken them down into 75 true samples for evaluations. So let me walk you through an example of what means by quotes. You can see the yellow highlight there quotes. 古今先佛愛 yeah, and continue. So I would like to have a little reminder is that the quotes haven't finished. It goes into the next page because of the screenshot. So we just didn't include it here. Yeah, and apart from the quotes, we have also extract something called topics. Yeah, topics. So this is our data set. So you can see we have paragraphs, topics, and we have some references. So you can see the topics are something like 有一位劉真人向其師演聖帝君, etc. and etc. From the examples, those topics are the descriptions of that quotes. And other than description, we may also we also include some names that are relevant to that quotes to be a topic. So the top why we have to include such a topic. This is also this will help us to do the evaluation when we are working on the topic retrieval. So it will be used in the later part. So after talking about how we build the evaluation dataset, now let's talk about the statistic of our evaluations. So we have a total number of 75 evaluation segments, and the total number of exact inclusion is 25. What means by exact inclusion? So on the left, that is an example. So on the top, that is a segmentation or a repunctuation did by professors, and he used in the papers in the quote. And the below one is the segmentation that we did. So we're trying to match between our segments and the ground truth to see, if we have additional punctuations, if our punctuation are placing correctly. If it's not correct, we'll deduct marks. So how we calculate out the score, I will walk you through later. But let me give you some examples and finish the statistic first. And from the graph, you can see this is the distribution of the match percentage. 100% match means exact inclusion, so there will be 25. And to be concluded, the accuracy of 80%, there are like 70% of the segments, they have 80% or above inclusion, which means there are more than 70% of our segments has achieved 80% of accuracy. Okay. And after talking about the statistics, I would like to mention some of the observations that we observe in doing this text segmentation. Is that there may be some errors in the source text that may cause some of the drops in accuracy. For example, like from the quotes we extract, the scene is 先人嘅先, but from the original text, that scene is 先後嘅先. This will also affect how we calculate the scores. That's why we may have some, it will lead to some drop of our accuracy. Okay, go to the next part is the algorithm. So how we are going to evaluate, really calculate out the score, the accuracy, the match percentage. So the algorithm we use is dynamic time mapping, and we use it to align our segment and the ground truth. We try to calculate the cost to match the ground truth. The larger the cost, the lower the accuracy. So in the below that is a cost matrix. What it means is like if our segment skip a word, so it may deduct 1 mark or up to k mark. It depends on how long is skipped. And also, if there's an incorrect match, it will deduct 2 marks. If it's correct match, then it remains 0. For better illustrations, we have an example in here. So you can see that the ground truth 古今先法愛 I'm sorry for that, and etc. You can see that the scene is incorrect, so it deducts 2 marks. It skipped the first stop, and also it deducts 1 mark again, and etc. etc. So in total, it deducts 4 marks. And after we have deduct 4 marks, we have calculated the percentage, which we have calculated the length of the ground truth, and we try to do a percentage calculations to see how many percent of the of our segments match with the ground truth. Okay, so after talking about the text segmentation, what we can do with the text segmentation, we can do visualization, and I will hand this part to my partner.
So after text segmentation, in order to have a better understanding of our segments, we have visualized our segmented data. To visualize them, we first have to convert them into numerical values. Then we can plot them into 3D space. To complete this task, we have used the AI model from the Beijing Academy of Artificial Intelligence. And generally, after we have converted them into factors, generally, when segments have similar meanings, they will have a closer distance. Yeah. And after we have converted them into a factor size of 1024, because we have to visualize them, we have to further put them into convert them into a 3D space. So to do this, we have used a tensor board to build an interactive projection of those vectors. With this tensor board application, we can zoom in, rotate, search, or highlight, and we can also locate the k most similar paragraphs if we just randomly selected a point. So let's look into the demo video of our tensor board. Yeah. So as you can see, we can rotate our graph, and if we point at a point, we can see what segments the point is representing. And if we click on the point, we can see the k most similar segments. And finally, we can search about segments, like to find out which points are most related to our query, as shown in here. Okay, so this is the end of our visualization part. Yeah. So I'll hand it into my partner.
So now we will talk about the method on doing the topic retrieval and the evaluation of our method. We start with the fact that computers and machines only deal with the numbers, so we have to convert all our natural language text into numbers to let the model determine which sentences will have the most similarity with our query. So we first pre-process the text by dividing them into by the volume and some data cleaning approaches, as mentioned before. And then we split the data into chunks. So note that this chunking of text is regardless of the segmentation we talked about before, because the segmentation before is for human reading, and this chunking is for the machine to learn. So with 300 words as a chunk and consecutive chunks have 100 words in overlap, the machine could better capture the global meaning of a paragraph, and hence the retrieval could provide more robust and relevant result for a specific topic. As for the evaluation part, our group collects quotes and the description on呂祖全书from the 3 academic papers I mentioned before, where in total 25 quotes are collected with 53 different descriptions as labeled. So the evaluation first starts with retrieving 3 most related chunks based on the topic. Next, it traces back the segments that are related to the chunks. So, and then we evaluate the result by the DTW algorithm mentioned in the test segmentation, but with the punctuation ignored. At the right-hand side, you can see is an exact matching example where the ground truth collected from the academic paper is 100% included in the output segment. We can have a look at the statistics. We in total evaluate 53 segments, and 37 of them have exact inclusion from our method. And more than 96% of them have 80% or above of ground truth inclusion. Next, we'll have a few more exact matching examples, like here. Yeah. So additionally, we have discovered some observations from this. Although we retrieve 3 most relevant text segments, they may not be the most relevant text as mentioned in the academic paper. So this can lead to a little bit drop in our accuracy. Also, we found that the longer the description will give a more accurate result as it contains more information in the description for the retrieval. So using our data retrieval strategy, it can facilitate cross-text search as shown at the right-hand side and offer detailed description of the source text.
Okay, let's come back to me. So after we have talked about all the technologies that we have used, like the text segmentations, the topic retrieval, so we have tried to now we try to combine them all together into one interactive UI. So this is the snapshot of the UI. So allow me to walk you through some of the elements of the UI first before I show the demo. So you can see there's Kwong, and there's a drop-down menu there. So in that place, we can click the drop-down menu and select the volume that we would like to read, and we can select the paragraphs that we would like to read. First, this interactive UI is an ebook for the public to read the 呂祖全书 with the help of our text segmentations. And after that, we also offer the source text search 原文搜尋, where you can input some of the words and find some of the relative paragraphs that appears across all over the passage. Apart from that, the most important part is the 主題搜尋. So we can type any of the text in the 主題. For example, like the 黃成遠係for example, like you can type 黃成遠, or you can type like 柳真人或者正演演正帝君, etc. to search for some relevant text that is some of the text that is relevant to your topic, and it will appear down below like this. After you have retrieved the text, you can also select the paragraphs and to give a feedback. And why we have embedded this function? Because we would like to facilitate future work to build a data set to facilitate future work. So let's watch the demo first. So this is the demo. Okay, in here, you can see that we can click the next sentence, and the users can just read like a normal ebook about the 呂祖全書. It helps them to somehow get over the barrier that it's too hard to read such a text for outsiders. So you can also jump to a volume or a paragraph that you would like to have. After that, you can do the topic retrieval in here. Like you can search for 修真. Yeah. And that will be some paragraph that is about 修真. Just like what we have mentioned, if you put a longer description, you can search for a more accurate text. And you can also rate the paragraphs that you have just searched, and it will input back to this database. Yeah. Okay. Yeah, it will input back into this database. Last but not least, we have 原文搜尋. And okay. So this is a summary of our UI. And at last, we'd like to mention it. We'd like to recapture again. What is the use case, or what is the purpose of our interactive UI? First, for the public, it's easier to read. It helps them to read 呂祖全書. And for researcher, well, hopes that it can help you. For example, like if you remember, there is an event happen mentioned in 呂祖全書, like 呂祖發生乞丐
去一個插棚去考驗一個女子 then you can just type in such a phrase into our topic retrieval and it will retrieve relevant paragraphs. So it may help you to do citation in your academic search. So that is all of our project. Thank you very much.
Thank you very much, and CCC Henry and Sheng. Do you have any questions from the audience? Any questions from online or from the audience? Yes, Ryan, please.
Yes.
I saw your search support the fuzzy search, and also I noticed when you do the demo, right? I think the topic, there's a ranking. I think not the exact word is in your ranking. I know the fuzzy sometimes they will embed some of the ranking. So could you explain why the exact term is the second or the third one, not the first?
Oh, okay. Before I answer the question, I would like to talk more about the fuzzy search. For the fuzzy search, it is mainly the function for the 原文搜尋 that one. For example, like can I have an example like in here, like 學者知十迷八九聖詩口口 something like that. For example, if you miss two of the words in the middle, it just search for the head and the tail in the 原文搜尋. It can also return such a text. And respond to your queries in a demo, like you search for 修正 and paragraph that is related to 修正 appears in the second and the third paragraphs. In here, we like to emphasize that the topic retrieval emphasize on the global meaning of the paragraphs. Like the whole paragraph is about 修正, but there can be none of the words word 修正 appear in the text. So that is the power of the topic retrieval. That's why it can achieve, like you input a description and it retrieve a text that is related to that description. Yes.
Yeah, Professor Lai, please.
Following these questions, even you have retrieved the word 修正, but the meanings, the various meanings of 修正, how the reader can be learned from all these retrievals.
For this, thank you for your questions. For this one, we have talked with our coaches for a long time. We have actually we have already built like 3 different versions of our demo of UI, and some of our version has embedded a LLM, which is, for example, like something similar with ChatGPT, but we use a model called Sunzi, and we try to use the LLM to explain the words like 修正 by reading this kind of text. In another version of our UI, we have embedded this function, but allow me to tell you why we didn't show you in here, because as we know, as an academic researcher, we look very seriously on the evaluations, and up to now, we are still struggling on evaluating the answers that the LLM gave. So as an experimental functions, yes, we have such a functions that we have presented in some of the progress sharing before, but to be a serious presentations, we just put it aside first. So maybe in the future we'll do it.
I think that we can achieve these goals. For example, we can I don't know how to devise a function that to find the definition from the text.
Okay, find the definition.
Yes, I think so. Yeah, I don't know how to input the commands for the AI, but I think that within the text itself, there's certain paragraph
okay,
addressing to the meaning of 修正.
Okay, I get your meaning. Quick response. Somehow maybe we can input like 修正的定義 in the topic retrieval, and it may appear a text that is like a 文言文 that talks about what is the definition of 修正. So we'll try it later. Thank you very much. Any questions?
Any question from Alice? No. My first impression is that the useful values for your experiments on the final parts that for can you go back to the final part?
This one?
For example, so you have a good examples when reader have an impression that there's a certain stories about Lü Zhu, which can be identified in the text.
Yes.
But he or she forgot of where and what exactly. So he or she give some hint, and the AI's machines will give him or her back the exact paragraph. I think this is very useful for scholars. You know, the machine's memories always replace our human memory. So it's very good.
Thank you very much.
Yeah,
that's a great
yes.
accomplishment.
And I think the AI machines can be cultivated and also nourished in these ways. I think it's very good.
Thank you.
But for segmentation and visualizations, I can't figure out what the AI values for these functions. Please, can you explain furthermore?
Okay. To be honest, for the visualization. Okay. Let me just continue. To be honest, I think for the visualization, the most attractive part for me is very beautiful. Yeah, because it can roll and it can do a lot of fancy stuff. You can click and it display. Okay. For scholars, I think it achieved the similar functions like what we have mentioned, like search for similar paragraphs. Because in the demo video, we show you that you can click on one of the points and it could return you some of the similar paragraphs in here. Somehow it serves similar functions. But it's just comparing the factors, and it can earn, how can I say, it's just like doing a topic retrieval, but you are inputting the whole passage, this segment into it. So it's just internal comparison. But the topic retrieval, you can use some external text to search for it. And this is, so I think it serves similar functions for the scholar with the UI that we present later. But for public, I think such a demonstration could really attract them to really just play with it, to see with it, and then like put it in the front page of the screens. And after they click inside, they can use our UI. Yeah.
Do you find the values for this visualization? Yeah.
There's one thing that I could also mention is that you can zoom in and you can check for the clusters. Like similar text, they somehow cluster together into one place. So I can't really do the real demo in here, but you can see if you click the T-cent separations, it will further do the clusterings, and you may see some of the text will gather in here, some of the text will gather in here. Once you click into one of that text, you could see that, they are similar, they share similar meanings, or they have some words. Somehow, it helps you to gather all the texts that have similar meanings without you giving a label. Like without you giving 收整, it can gather some of the text that is somehow mathematically related. So that may be one of the parts that helps scholars to extract information that you haven't thought about, or if you even if you don't have in your mind you don't have a topic, you can just read through those clusters and maybe you can search out for a new topic from those clusters. Yeah, that will be one of the use case.
I have a rather basic questions.
Yes.
I wanted you to talk about more about the method that you retrieve the topics. The reason why I ask is that I saw like a little Excel table at the corner, and then that's 2 words, there are 3 words, there's 收真, there's 收真. How do you create that list of 主题 or topics or themes from the text? And how do you, in a more simple way, how do you split the text into characters and terms that you find it useful for topic searching?
You mean this table or the table that at the previous slides?
I think it's a more general question about how you pick the topic, basically.
Okay.
And what's the method do you use, and how do you define it's a very valuable topic for that text?
Okay, so if you're asking me about how I choose the topics and it's valid and relevant with the text when we're building the evaluation dataset, then I would say somehow we did it manually with common sense from the academic paper that you can definitely read it by common sense that, oh, in this sentence, in the paragraph, it is talking about this and they are related. Yeah, so I believe this could be done by common sense. Yeah, yes, just they stick together. And
from your experience, I'm genuinely asking.
Yeah.
If the text it's more than the Chunshu that you're working on. For example, it's a huge Daoist canon.
Okay.
Any suggestion or what's the method that you will be applying to for that topic retrieval?
Then for that one, one of others of our groups, they have shared about LDA. They use that method to retrieve some of the topics without labeling from the text. And somehow we have thought about that method before, but due to somehow this kind of evaluation or this kind of data collection is somehow more efficient because somehow manually doing things somehow faster. Yeah, so we have adopted this time. But if we were to scale up, like if we not only do 呂祖全書32卷, but we do 64卷, or even we do 引流古書引流藏書, then somehow we may use LDA, use a mathematical and algorithmic method to extract topics without supervising or manual labeling. Thank you for your questions.
Cool, to comment. I know you're using a Professor 3 article. So do you think is this sufficient enough for you to do the ground truth, or actually you should have more data?
Okay.
My second comment is like Professor comment, you have three separate tools. The other two probably not relate to the first one. Is it possible you can integrate in one? For example, you do the search, then you can see the clustering to see this passage is related to the other one. So you can make sense for your ranking or your topic. Just a comment.
Let me answer your second. Let me respond to your second comments. I would say definitely yes. Yeah, thank you for your questions. Thank you for your comments. And I think that will also be an interesting visualization. And for the first comment, I would say more is better. Yeah, but due to time limitation, we have just collect. Because every time we do this evaluation, we have to read through the whole papers, and somehow I'm so familiar with that paper after reading. But due to time limitation, so we have just collected 25 quotes. And somehow more important is that it's hard to find passage, academic papers, some I can say qualified enough academic papers that is really talking about 呂祖全書 and have quotes that is 呂祖全書32卷 but not 64卷. Somehow it's hard to find. We discovered. Yeah, so that's one of the obstacles.
The integration between the raw data and also the scholarly work. My further question is, can the AI's retrieval functions can challenge the papers?
Oh,
yeah, because all these three papers are coming from one scholars, but for AI's machines, so we want to build a large data set. How this setup can enrich and also expands one scholar's understanding of the text. So this is another ways of questions how the data set can enrich and then challenge any individual papers. Is it okay? Do you understand?
I understand. 80% I understand. And I would say, because the model that we are using to do a topic retrieval somehow doesn't involve training or with this evaluation data set. We didn't use the data set of this paper to train it. We just use it to evaluate it. We assume that this evaluation data set is correct. Somehow, after we do the, for example, in behind, we have something that is like this one. Although 各為正確, this one is not from 32卷, it's from 64卷. But somehow, after you retrieve this text, scholars may try to read, they can able to read such a passage below and to see, to challenge itself. Yeah, but this part is, it depends on how the scholar use it. But taking your comments, we could also think of how we facilitate the scholar challenge itself. Yeah.
Not only the facilitation of the challenge, but we always give the AIs a positive value that it will open up the research future. So I think this is one of the values for mutual reciprocal ways of evaluations, not only the data set, but also the previous scholarly work.
Okay. Need some time to digest. But never thank you.
Thank you very much, Professor Lai.
It's okay, yes. I look forward to your further successful attempts to use the AIs in its as a research tool for humanities. So I think it's very future looking for integrate AI and humanities study, especially the classical text studies. So yeah, okay. Yeah, thank you so much.
Thank you. Thank you very much, Professor Lai. I really appreciate coming here to review the presentation and giving us the valuable input. Thank you very much, CCC and Henry and Shen, for your excellent presentation. Thank you. So next we'll have our fifth group. It's by Gasing and Cheung. Yeah, please come. Thank you.
Okay, good afternoon, everyone. My name is Anthony, and I come from Statistics Department, and this is Sam from Computer Science Department. Today, we are excited to talk about our project, the topic called the Chinese Modern Poem. Okay, so what is our motivation? Our motivation is because we find that the Chinese modern poems can be hard to understand even for Chinese. So in this project, we will generate the image for each poem to visualize the core message of the poem. And also for better understand, before we generate the image, we will do some basic data analysis also, so that this can give us some insights of the Chinese modern poem data sets, including the sentiment, the wording capacity, and also the word counts. So, what is our data set? We use 小說與詩 from the CUHK digital repository. One of the example issue is shown in the screen, and because the 小說與詩 data set have both 小說and poem, we will use only the poem in our project. We can see that in the screen, each poem data will include the poem's title, author, content, and also the number of issues. Finally, we will have total 45 issues with 461 poems, which the year range from the 2013 to 2024. Okay, for the basic data analysis part, we are interested about how many words in our poem data set. So we generate the word count distribution and also the box and whisker diagram. To be concrete, there are around 100 words in FH, but some of them are quite long, like the small circles shown in the box and whisker diagram, and they count as the outlier. Beside from the word count, we're also interested about the sentiment. So we calculate the sentiment score for each poem. And the sentiment score defined as the range of from the 0 to 1. 0 mean extremely negative and 1 mean extremely positive. So we also generate the sentiment score distribution and the Bose and Whisker diagram, and we find that most of the poem are in range of sentiment score 0.0 to 0.2. So that most of them are quite negative. But beside from this, we find that there are some also extremely positive. So our poem data set is quite extreme. Yeah. And beside for the sentiment score, we also calculate the wording complexity for each poem. And higher wording complexity score mean more complicated word use and less more complicated word use and less common word use in the poem. One of the example is shown in the screen, and this poem is the highest complicated score. And we find that why it have the highest wording complexity score because it uses a lot of complicated word and phrases. And beside from that, we also find another higher wording complexity poem, and we generate them for using the bar chart. And up until now, we talk about the wording capacity, the word count, and also the sentiment. We would like to find, are there any relationship between these variables? For example, maybe high word count may lead to high wording capacity. So we would like to generate the correlation matrix to find this answer. We find that the correlation coefficient of this variable is very close to 0. So this means that there is no relationship among all the 3 variables we mentioned. And like other group, we also generate the word cloud to find are there any popular words or vocabulary used in the poem data set. Beside from those common word, we find that 天空, 城市, and 世界are most popular in our poem data set. And beside from those basic data analysis, when we briefly to see our data set, we find that there are some authors often appear. So we would like to generate the cumulative distribution to find the number of poems that the author have. Actually, we have totally 461 poems, and we find that there are 318 unique authors. This means that maybe some author will have at least 1 poem in our data set. And we find that 23 authors will have at least 3 poems. So what is this 23 author? We also generate the bar chart to show that. We can see that the highest number of poems is 魏彭展先生, which is our editor of 小說與事. And he will have 35 poems in our data set. And the second one is 水形作者, which have 20 poems. And also, we calculate the FH sentiment score for each author. And for example, for those 23 authors, we also generate a bar chart to show them. And specifically, 魏彭展先生 will have a 0.18 score, which means that he is quite his poem is quite negative. And also, 水形作者 will have 0.49, which is more natural. And this is all the part of our basic data analysis, and Sam will give an introduction of the image generation.
Okay, so thank you, Anthony. So let me talk to you about the image generation. So first, I would like to remind you the motivation why we're doing this. As mentioned in the introduction part, oftentimes Chinese modern poetry is very hard to understand, especially for Chinese. Like me, sometimes during my study in the DSC, I find it pretty hard to understand. So what we do is trying to generate an image for each of the poem, because oftentimes people say one picture is worth 1,000 words, right? So for example, in this poem, we will have a generated image like a soul. Okay, the poem and then the image. And then how are we gonna implement this workflow? This is the big picture, the big overview. Okay, first we will, idea is to use large language model, and it's a automatic process, not a manual one. So we're using scripts to do it automatically, not manually, sorry. And then the workflow. First, we will analyze the poem. We'll ask the LM to analyze the poem. Then after the analyzation, we'll get the poem. Then from the poem, we'll generate the image. After generating the image, this is a pretty crucial step, and it is to evaluate whether the image is good enough or not. We'll do it using another large language model. Okay, there will be two outcomes after this evaluation process. Number one, if the image is good enough, then we'll just call it a day and save the image. And then number two, if the image is not good enough, then we'll do the regeneration process again with the suggestion from the evaluator. So two regeneration process will be, there will be at most two regeneration because we try to save the cost. Okay, so let me walk through in greater details. As mentioned before, our first step is to do the analysis for the poems. And we have identified 3 key areas to do the analyzation. Number 1 is the key elements. Number 2 is the semantics, meaning the interpretation and the meaning of the poem. And then number 3 is the core message. Okay, so I think the core message is the most important one out of the 3. So we try to focus on it. Because the image, if it can represent the core message well, it doesn't really matter if it doesn't have most of the key elements. Okay, and then generating the prompt. So this is how we ask the large language model to generate the prompt for the image generation, which will consider the 3 key areas that I've mentioned just before, and the model will also choose a suitable art style. Okay, so this is the example that for the image generation, at the actual image generation, we just use the prompt that we gather and fit it into a image generating model and has such result. By the way, the model we are using is Gemini 2.0 Flash from Google, and also Playground VV. Sorry, there's a typo in the previous slide. Okay, and then the evaluation process. As mentioned before, evaluation is pretty crucial, right? So we have come up with a prompt to ask a third-party large language model to see whether the image generator is good enough or not. And then here are the metrics. Number 1, the appropriateness. Okay, this is actually a pretty important one because without it, the image might not be age appropriate. I've tried it before. However, after careful work, now I can say most of the time is generating very appropriate images. And the other metrics include the core message or the key elements, the semantics, and also the technical detail, the quality of the image. So I will give you a, let's see, the regeneration process. Okay, as mentioned before, if the image is not good enough, we'll do another one of image generation. So the prompt for the image regeneration is like this. It will consider the suggestion from the third-party evaluator, and then to save the cost as mode 2 rounds will be conducted for each poem. And then here's the demonstration video. Okay, so we are using a script to do this automatically instead of doing it manually. Okay, refresh. And then this is the first prompt. We are asking the large language model to consider the Chinese modern poem and to analyze it. Analyze the key elements, semantics, core message. Okay, and it's pretty quick. So this is a poem. This is the same one that we've shown before. And then this is the analyzation. Okay, you can see that we got the key elements. We also get the semantics, and the core message. And the large language model thinks that this poem is about how fear makes people not want to help others, and it makes us wonder if it is us or society that is really the problem. So I think later we will look back into the poem's content to see whether it's true or not. Okay, so this is asking the large language model to generate a prompt for image generation. And then this is the prompt for image generation. We feed it into the image generative model, get the result, and then move on to the evaluation step. Okay, like so. So we ask a third-party large language model to evaluate the generated image. And then we also put in the metrics, the 5. So it will first analyze it a bit and then process each of the metrics for evaluations. And lastly, if give the conclusion, in this case, is about saying that the image is actually good enough, which in my humble opinion is actually correct. Okay, and then back here in the Visual Studio Code, we can see the result, and we can see the generated image is saved. So this is a little demonstration. Oops, let me get back. And this slide. How are we going to represent the result in our website? So right now, we are thinking of representing them in a gallery view-like structure. So for each of the issue, there are 113 poems, and we'll put all the images and the poem's corresponding title into a gallery view. And we'll also make it interactive. By that, I mean the user can click onto an image or a title and feel the body of the poem. And then future work, what are we gonna do? Well, we are gonna complete the website and the poster. Maybe we can add user interaction within the image generation workflow. That's a potential improvement. And then another one is to represent the result in a network graph view. So I think I get back to this, actually, the poem. Now, this is 我病了還是這個社會病了? I think it is pretty well represented by the large language model. The large language model has a pretty good understanding of it. And this is the result. I think it's pretty matching. Then on to the summary. What have we done? Well, we have performed data analysis on our data source, that is, CUHK on various aspects, like the word count, the sentiment, the wording complexity, and about the author. We'll also perform data visualization to show our analysis. Then we have implemented a closed loop image generation workflow to better let user understand each poem. And then acknowledgement. We would like to thank the following people. Pan Jin先生, which is the provider of our data, the 主編 of CUHK. We would also like to thank our coaches, Mr. Ryan Lee and also Dr. Casey Wong. And we would also like to thank the guests and also the project coordinators. And the following 2 papers are used and referenced. So this is it, our presentation, and we can accept questions from you guys.
Thank you very much. Do we have any questions from the audience or online?
Yes, please, Professor Lai.
Starting from the beginning, you also share your difficulty to understand the poem by itself. So I think that all the further AI work is mostly built on the reading itself. So who read these poems? You and or the AI to read the poems first, and this is the most important question. And the second, who input the semantic and also the key words and also themes into the AI's operations. So, and then the final picture, the image generations. It seems that the AI generates the image on the basis of all the data's input. But so if the readers who understands this poem is different from the AI, so the image generation will be different. And for example, as readers in Hong Kong, so I look forward to an image coming from Hong Kong daily life. So whether it's possible instead of the Western styles image.
Okay, so 3 questions. Number 1, whether we first read it or just don't read it and let the AI understand it, right? So I think this project is about assisting our understanding on Chinese modern poem. It's not about letting user don't have to read it at all. It's about enhancing our understanding. So I think it will allow people to read it and then see whether their understanding match with the actual meaning by checking along with the image. So it's more of an assistant. And then the second question was about. Sorry, can you repeat the second question? Limited memory. Oh, yeah, the input. Okay, so the input is actually an automatic process. We will actually have the first process as the analyzation of the poem, and it's actually done by the large language model. It's not done manually, so it will extract the key elements, the semantics, and also the core message by itself. Like I said, this is a prompt. And then the extracted information will be used in the next procedure, which is about generating the prompt for image generation.
In this way, you as the author of this project, so what's the role that you conduct besides all the work you rely on LLM? So what's the role and also the part you play in this project?
Well, the part is about building an automatic workflow and actually verifying whether it is working or not. Like, for example, in the earlier development, we have found several limitations or several difficulties that we have faced. For example, the appropriateness of the image generated can oftentimes be less ideal, like having too many creepy elements or too many violent elements. We don't want that, so we have to fine-tune our prompt. And yeah, I think that's it.
Do you have any other questions? Ben, please.
Thank you for your presentation. My question is on the audience for the images that your system produces and what your decision-making process was to choose a website as the way to best reach the audience that you're aiming these images for.
Okay, so our target audience. Our target audience will mainly be the general public who are interested in reading the Chinese modern poem instead of the researchers. Okay, because the researcher, they are already very capable of understanding, they don't really need these images. And then the representation in the website. So in this project, we are required to represent our findings in our website, and we think that this gallery field could be a good representation for our findings.
The generation is very subjective.
Yeah.
So the how can we evaluate and assess all these the value of these image generations?
Yeah, so our group takes a rather empirical approach, I have to admit. And we just fit it into the large language model to see whether the quality is up to our standard or not. So, this is a potential improvement. Maybe we take some more rigorous approach, make it more quantitative, use some number, do some statistics, make some graph to see whether it's good or not.
I think we have some discussion. One is the writer intention. The other one is the receiver. How the receiver to receive this message. So I saw your one of the approaches using the AI to challenge the other AI. That kind of approach. Probably we can involve some human evaluation in your process. So like you say, you can invite people to say this appropriate or something message you want to add on to see the difference. But at your beginning, you say this is a assist the user to understand. Maybe they can have a different insight or not. Yeah, just as a comment.
Thank you.
Any other comments or questions coming from the audience? Anything online from the Zoom chat? All right, if not, thank you so much, Cheung and Jiaxing, for your wonderful presentation. We've learned a lot from you. Thank you very much for your time and effort. Thank you for the reviewers' comments and questions as well. So thank you to all of our student presenters for your wonderful presentations today. I feel like I've learned a lot from you, not only just from today, but throughout the semesters starting since I started working here. So really appreciate all your hard work and your efforts. And also thank you for our invited reviewers for your presence and for your valuable comments and input. We really appreciate having you here. Thank you very much. So this session actually concludes Data Excellence Week 2025, organized by the CUHK Library. We're very grateful for all your participation in our events this past week. Now, we're very delighted and honored to have our university librarian, Mr. Benjamin Meunier, to deliver the closing remarks to conclude the Data Excellence Week 2025. Thank you very much, Ben.
Thank you, Chin. Where do I stand for the camera to see for the video? Okay, fabulous. Great. So, good afternoon, everyone. It's been a fantastic week for our first Data Excellence Week after we rebranded from the Research Data Management Week. And I just want to take the opportunity to reflect a little from the opportunities I've had over the last few days to witness the activities of the students, faculty, and library colleagues and other units who've been involved in this Data Excellence Week 2025. The final presentations of the data analytics practice opportunity that we've just seen showcased the excellent work of students in data mining, analytics, and visualization skills. And it was a real pleasure and a treat to catch the end of the presentation. So I was very much impressed with the presentation. And I also thought that there are some real opportunities to help with using data to engage audiences in new ways. One of the challenges with the generation of TikTok users and social media users is it's quite hard to keep people's attention for more than a few seconds, if that. And I think if we can produce beautiful images or thought-provoking images that might pique interest of an audience, it might then lead the readers, the viewers, to want to understand a little more about what this is coming from, and it might be a great way to engage with classical Chinese poetry. So I think it was a really good illustration of the power of research data to produce new insights and to engage audiences in making meaning out of data. This week, we've had a lot of activities, as I mentioned. On Monday, the workshop on the effective use of the CUHK Research Data Repository helped to provide users with an introduction to the Research Data Repository, which serves as one of the foundations of good practice in research data management in CUHK. It's a service which the library has run for the last 3-4 years, and which provides support for anyone who produces research data sets, whether those are research students or faculty. We have a place where we can safely provide access to research data sets in line with best practice internationally and in line with the FAIR data principles. Hopefully, all of you by the end of today know what FAIR stands for and what the FAIR data principles are. I see some smiles and some nods around the room, so that means you have been awake during the course of the Data Excellence Week, which is excellent. Then on Tuesday, we had an excellent presentation by our keynote speaker, Professor Thiemann from the University of Hamburg, providing us a perspective from Europe, from the University of Hamburg in Germany, and understanding developments around research data management practice in Germany and learning from the different ways that they have built connections across departments in their institution and worked with other units on campus on different research data management initiatives. Yesterday, we had the faculty panel at the Data Champions inauguration, which showcased the cross-disciplinary collaboration which happens here at CUHK around research data, and the discussions and dialogues that happened brought forward some of the ideas and thoughts of our data champions who are starting now on their journey and will be supporting and serving the university for the coming year in promoting good practice in research data management. And if there are any data champions in the room today, then thank you for putting yourselves forward. And we very much look forward to working with you to help instill best practice in research data management and to strengthen our research data practice across the university. Moving forwards, the research data team, led by Chin, will continue to enhance our research data management services through collaboration with faculty members and other stakeholders on campus. And by leveraging the network of data champions we're establishing across the campus, we will drive forwards promotional efforts to drive research data management related initiatives and services across faculties and programs here at CUHK. I want to take the opportunity also to thank Chin, who, as she mentioned, has only been here for less than a year. And this has been a wonderful opportunity for the research data management team to showcase the experience and the strength that we have within CUHK Library to support the academic community and the approach that we're adopting, which draws very much on the expertise of our academic colleagues to also help shape the way that we want to develop research data at CUHK. Thank you so much for being part of our research data management journey at CUHK. We look forward to working with you from CUHK Library and our continued dialogues and collaboration around research data management. Congratulations on the successful completion of Data Excellence Week 2025. Thank you.
Ben, oh, okay, I'm on. Thank you very much, Ben, for your closing remarks. And I would also like to take this opportunity to thank my wonderful colleagues here in the room from CUHK Library and also community members like our professors and reviewers from across CUHK campus. I think this really showcased the synergies and collaborations across discipline areas here at CUHK. And this event wouldn't be possible without your help and support in many aspects. So really thank you so much for your participation, your support, and help in all aspects. And that's pretty much concludes the program. And thank you so much, everyone. Enjoy the rest of the day and have a great weekend ahead. Bye. Thank you.